Okay, we can see and we can listen to you, so let's go on.
Okay, that's great. A pleasure talking to all of you. A real shame not being there, but hopefully the next time I want to visit. Well, I'm going to talk about some of our passive house projects. This is an image that we like to use as our first slide. The truth is that we've got lots and lots of reasons for building passive house or NSEP buildings, simply building better. But one of the main reasons has to be what we can see here. Passive house might not be the solution for all the problems that we have in the cities, but it can be one of the biggest solutions in our cities. The contamination 65%. If we can reduce these emissions in 70, 75, 80, 85%, we are going to do a great advance. Okay, we are a small team from north of Spain. Actually, we have finished close to 400 passive house buildings. And actually, we are working more than 1,000. We finished 3 years ago the first passive house residential building in Spain. We finished also 4 years ago the first Congress Center in Spain with Michel Bassouf. We made the passive house assistance. We finished really short ago the first passive house health center, and we also finished the tallest passive house in the world. This is the project which I'm going to use for the beginning of this presentation. This project is in Bilbao, in the north of Spain. It's in an area for 1,100 apartments, and it was an architectural competition in 2012. The object of the competition was the two towers of the left, one with 28 stories and other one with 20. Well, we were lucky enough to have a huge crisis in Spain. There was not money enough for almost any project. So the district heating that was going to be in all this area for all these apartments didn't happen. So finally, the government asked that we should find a way for making this housing so efficient without that district heating. And this is where we started thinking about making this project passive house. It's not that after these little changes, we have to invest lots and lots of time for all these small details that seem that are not so important, but definitely they are. Well, already all of you know the 5 really important basics of the passive house. The thermal envelope is, of course, outside all of the building. Inside of this thermal envelope as non-heated spaces. We have to use the lateral full so we can have a continuous line of insulation outside the building, in plants, in section, in every part of the building. And here in the right, we can see some of the U values of this building. These are not crazy values. As you can see, we are using 0.22, 0.24, not really so low values. The truth is that such a big building is going to help really a lot. And of course, the soft climate in Bilbao is also a very important thing. Well, this is a bit tricky. This is not really a picture of Bolueta, because in Bolueta we have very small balconies. But for the purpose that I want to share with you, it's good. In a normal apartment building, we would have a balcony, and of course it would have the same slab as we had inside of the houses. This means huge amounts of energy going outside of our building. If we break these slabs and our insulation goes without any interruption, of course this is going to be incredibly more efficient. We can use some commercial connectors, but they are still a bit expensive, so we can use the cheap way. Just calculate an additional, all these parts. Here we can put an EPS to solve this thermal bridge. Of course, instead of a linear thermal bridge, we are going to have punctual thermal bridges with a much lower value. Some things that at least in Spain we didn't usually insulate. What you can see in blue is the acoustic protection for the drainage. Well, we need to insulate them with at least 5 additional centimeters of insulation so we can reduce this thermal bridge. We are not going to make it disappear, but we are going to make it to be a much lower value. About the thermal bridges, just connecting what we are talking about. This is not a very difficult building in this aspect. I mean, we've got quite a few thermal bridges, but they are going to repeat 1,000-2,000 times. So the most important thing is solving them properly, and after that, simply repeat it. Well, in which we have the cross section of the facade and the roof. Usually in Spain, we would have a brick facade going up in the corner. If we make this, we have a thermal bridge of 0.18 watts. Well, it's a quite high value. If we simply use an alligerated concrete block of concrete, of course, sorry, we are not going to eliminate this thermal bridge, but yes, we are going to be able of reducing quite a lot, as you can see in this image. This is a very simple solution, it's cheap, and well, maybe the builders are not really in love with this kind of solution because it's a bit tricky working with this material instead of the bricks, but it's really a solution that it's extremely easy, cheap. The same happens with the sections that we have in the windows. In the left case, we've got a normal window with an exterior insulation and an additional insulation inside. Well, this is fine. In fact, we've got almost the same insulation in the left and in the right. The problem is that we don't have a continuity between the insulation and the frame of the window. This is something extremely necessary. In the top, you can see the value of this thermal bridge. It's not huge, okay? But I'm not sure if you will appreciate that in the slide. We've got quite low temperatures inside of this window, around 15, close to 14 degrees. This means that we could have problems or pathologies with condensations. This is not something that we can have. So we have to go to the other option. Of course, we have to insulate the frame of the window. We have to get a continuity between all the insulation lines. In this case, as you can see for the numbers, it almost disappears, this thermal bridge. Well, the truth is that it's something that it's quite easy for making it in the side. So, especially in this cross section, we can see these little holes that are used for evacuating the water in case of rains and the window is open. Sorry. So what we used were some special parts made with EPS and some impermeabilization that we used to put between the frame and the outside part of the insulation. With this solution, we are going to achieve a good thermal bridge, and we are not going to have any kind of problems with the water. This is more or less the final look of one of these windows. As you can see, the frame it has around 12 or 13 centimeters, it's going to get just from the outside about 2 centimeters. About the windows. Well, this is such an important thing, and especially some aluminum with double glazing windows with very strong thickness for the glass. And regarding noise, the traffic. When we went for the passive house option, window quite similar, but the U value was the half. As you can see here, the annual energy balance, well, it's a huge gap. We are talking about minus 100,000 to 29,000. So, well, we don't have much to say. Can we make passive house with double glazing? Yeah, of course, but it depends of the location of the climate and of course the orientation. Well, we have many different things to consider. In this case, it was a good investment going to the triple glazing, because if we hadn't, we should have gone to another part for improving the efficiency. Something very important about the windows is the frame, the glazing, the warm edge, but of course the position, the collocation of the windows. We are not going to make anything good with a great window if it's not installed properly or without that thermal bridge that we saw before. We are going to use air tightness bands, different bands for inside, for outside. So important using a specific material, so we can be sure that we are not going to have interstitial condensations. We must be sure of the SD value, so the water vapor can go through the section without any kind of barrier. Well, something that we found in the beginning was how are we going to protect the windows. In Spain, and I think that is the same thing in Portugal, we put the windows much later. Why? Because we don't want them to get worn. So if we have to put them very early, so we can make the air tightness, the blower door and all these kind of things, we are going to protect them. Well, this is the first project that we made. Actually, what we are doing is this: put a first line of air tightness bands. After that, we can put the plaster. So we've almost finished the air tightness. A double band of air tightness over the last one. Well, this wasn't our first choice. Initially, we were a bit accepted about the results of this situation, because the bands were going to be instead of is that if the plaster is dry and they put them properly, the results are really good. Actually, we began in this kind of projects in apartments with 244, and actually we are in values close to 0.2, 0.18. So with traditional construction and this kind of bands, we can go to really very low air tightness. Another important thing was protect the windows, of course, for any kind of possible entrance of water. The image in the left should be a traditional option in Spain, a band that wouldn't let the water go all over the window. The problem of this thing is that it's a quite nice thermal bridge. We are talking about 2 millimeters of aluminum or something like that, and we have 2 meters for each window. If we have 3,000 windows, this means a thermal bridge with a length of 6 kilometers. This is a huge thermal bridge. The option in the right is a PVC frame that the builder of the windows proposed, and it's really a great solution because it has just 9 millimeters thick, but it has an alveolar composition so it has a quite good U value. In fact, let me is this solution. We can put all this you're not going to have any kind of water inside of the window, and the thermal bridge of this thing it's almost non-existent. Well, this is the thickness of the windows, are huge. These glazings are close to 52, 53 millimeters. And after we have done all these things, we have to work, of course, the airtightness and the heat recovery system. Well, we have many options, but actually what we are proposing in all these cases, it's individual heat recovery systems. Why? Because we need some different situations for all these apartments. It could happen because of this geometry or house should need a bypass and a free cooling during the night, and for this independence to all of the users. The truth is that as we are making also the airtightness for each of the apartments, seems quite logical in this way. As you can see, we have the heat recovery systems outside in the balconies. After that, we've got all the tubes that go for the impulsion and distraction. And well, it's a quite simple installation. And here comes the finally we are seeing that doing things with a bit of care, it's getting extremely good results. The airtightness. This is a little plan. We can see this red line in the top is what we mark as airtightness lines for each one of the apartments. The most important thing here was the service riser. We made lots of different drawings for the different phases that we thought that were going to be important for the building. Actually, all these drawings are old. They could be 5, 6 years old, but actually our solutions are much more simple, much more easy for making in the site, and of course are cheaper. Well, another important thing is that we are building passive house in the typical way that we were building before. I mean, we are using concrete, we are using plasterboards, we are using brick, wood. We are not using specific or so strange materials. We are using the same materials that we would use if it was not passive house. Apart, of course, the specific things, the heat recovery system or the airtightness stuff. Well, this don't laugh, please. This was one of our first trials for one service riser. The guy who was here was spent close to 1 day putting all this shit, all these bands. It was really a huge work, and the result was not really good. Well, it worked. We achieved being below 0.6, but it was really a very hard work and didn't seem a very durable solution. So we went to continue the brick inside of the apartment. We use a very thin brick for making simply the airtightness with 4 centimeters, and we can put after the bands plaster, 15 millimeters of plaster. For achieving better results, we've been making little things. As you can see, we put a little bit amount of mortar around. This is, well, simply a view before we can put the plaster. Very important, having very clean the floor and put an information 5 minutes before we can put the bands. And this black thing, it's a good a good thing that we found in one of the projects. We were using always tape for every solution, but the truth is that if we simply put 1 or 2 turns of a liquid membrane, the solution will be absolutely perfect. This is not a solution when we have 7 tubes, but for one or two installations or penetrations inside the air tightness envelope, it's a fantastic solution. Well, entrance in the house, in one of the apartments here, in which we have in the left the water, after that the communications, electricity. Before that, in Spain, we usually made a big hole and put all these tubes inside. Actually, this is the way we have to make it, so we can give airtightness to all of these tubes. We tried an airtightness sheet, but actually it was difficult to work, and the people here was not used, so we kept using the plaster. Well, this is what I meant with having very clean the work site. And after that, of course, we have little tricks for making more strong the plasterboard without destroying the earthiness. There are some commercial solutions which are good, but I don't think that we are getting better results with this than with the solutions that we spoke before. And the solutions are cheaper. Maybe if we are going to make one project for one single family house, these are good solutions. But if we are talking about housings, big housings, I would go to other kind of solutions. Well, this is finally the certificate that we got in March 2018. These are, in a gross mode, the overcost that we had in this project. As you can see, it's close to a 3%. And this is the reduction of the heating demand. If we assume about 10 cents of euro for each kilowatt, for the 361 housings, we would be reducing about 125,000 euros every year. So this means that in 5-6 this is important, of course, but probably is much more important this. This is a huge amount of tons of CO2 that we are not going to throw to the atmosphere. This is the same as if every year we could plant five football camps with trees, or if we took out of the city all these cars. Bolueta is being recognized in Spain with the Green Solution Awards, and also National Green Solution Awards with two additional prizes. It's been published in several architectural magazines in Spain, in England, Austria, Serbia, Germany. Well, and this is another project. This is the Congress Center Europa. I would like to share with you just a few fast examples. I'm finishing very soon. This is the Congress Center Europa, as I said before. This is a work that we made together with Michel Bassouf. It was an extremely difficult project because one part was a retrofit, another was simply an ampliation. It had a big auditorium. We were not the architects, we were just the assistants, and nobody wanted to listen us. Well, it was a success because we finished it and it's working fine, but it was really an extremely difficult project. This is the 29 Soto. This is the first passive house residential building in Spain. Well, this is a project that had quite a big repercussion in Spain. It appeared in the newspapers, in the TV, and it was awarded by Asprima as the best residential project with efficiency criteria in Spain, which was quite a big success for us because we are a small team. The owner is a small promoter. It's a very small building, so this recognition, this acknowledgement was really great for us. This project also has appeared in several magazines and so on. This is a passive house project for a sports center that hopefully we will start soon. This is a health center which is certified, and we finished it well really short ago. And the passive certified is about 2 weeks old, so it's really starting to run this second phase. We are very happy with this project. It's a very different project from residential. This is an interesting project, even if it's not Passive House certified. It had Passive House criteria, but finally we had to leave their tightness in the way because of the budget. But it's inside the series project, which is about the air quality inside of the buildings. It's a European consortium in which we are going to work with some experimental materials that are going to absorb or eliminate the bugs, the formaldehydes, and the toxic gases that are produced during the construction of the building. Well, it's a really great experience, but of course it's simply a European project. The truth is that we should now improve some of these solutions to standard buildings. It would be great. We are working in this building. We finished the structure and we are beginning with the facades. And well, it's going to be a Passive House certified building. In this building, we have improved some of the solutions. These are the parts that we are going to use for the thermal bridge. Is the thermal envelope. To the left, we have the balconies, which are huge, and to the right, the heated surface inside of the apartments. This is another project that we just started last week. Is for 128 Passive House here in Pamplona also. This is a project for some apartments in Pamplona, which are going to be Passive House and are going to be made with wood. They have around 10 levels and are going to be probably the tallest CLT building in Spain. This is a project that we're going to start very soon also for some laboratories. And well, these are not Passive House projects, but it's a competition that we won in 2015, in which we worked with the insulation, the thermal bridges, and the windows. We had Passive House criteria for these three parts, but sadly the project was not about the inside of the housing, so we didn't work with the heat recovery or the airtightness. The truth is that this is what we proposed, and finally this is what is happening here. They have reduced hugely their heating demand and their comfort has increased in a crazy way. Well, we've got really lots of reasons for making Passive House, as I said before, and if you are not concerned, if you don't care the health of our planet, you can do it for your own health. We can do it for being more comfortable in your house, and of course, you can make it just for money. There are lots of reasons, and all of them are good. But simply, if you can make it better, we don't have to make it any other way. And that's it. Thank you very much for your attention.